Okay, greetings folks. This is the final study guide. Item 1 reads, tell what the mass number of an element says about its nucleus. On the periodic table, each element usually is listed with an atomic number, which is smaller, and a mass number, which is larger. The mass is larger because it accounts for both protons and neutrons, and that is indeed what the mass number of an element says about its nucleus. It tells you how many protons and neutrons, the mass of protons and neutrons together. So that's how I would answer this. Tell what the mass number of an element says. It says how many protons and neutrons are in the nucleus. How many protons and neutrons are in the nucleus. This was covered on day 12, which was vocabulary, but mainly we really dug into it on day 13. Okay, when we introduced the isotope concept. Lithium has 3 different known isotopes. All 3 have the same atomic number 3, but the isotopes that are heavier contain more number of neutrons. So the mass number is the one up top here, mass up top, atomic number on bottom. The mass number includes 3 protons and 3 neutrons for this lithium, which makes 6. The mass number for lithium-7 is 3 protons and 4 neutrons, which makes 7. And the mass number for this isotope is 3 protons and 5 neutrons, which adds up to a mass of 8. Explain in your own words what the mass number counts in the nucleus and why it differs from atomic number. Well, atomic number is just protons. Atomic number is just the protons. Explain in your own words what the mass number counts in the nucleus. It counts protons and neutrons. That differs from atomic number because the atomic number is just the number of protons. The mass of bromine is given as 80 on the periodic table. It's actually 79.9, which is really close to 80. What does that tell you about the nucleus of bromine? It tells me that the particles add up to 80. Okay, so on average, there's 35 protons and about 45 neutrons, which adds up to 80. The mass of bromine is 80. What does that tell you about the nucleus of bromine atoms? That they contain 80 total particles. Protons plus neutrons equals 80. Multiple choice. The mass number of an atom tells you A, the number of protons only, B, the number of protons and neutrons, C, the total number of protons, neutrons, and electrons. Okay, so technically the best option here is B, total number of protons and neutrons. True or fix, the mass number changes if an atom gains or loses electrons. No, electrons are negligible. They don't really count. All right, so mass number would stay the same. This is a fix. We should say the mass number does not change if an element gains or loses electrons, or we should say the mass number changes if an atom gains or loses neutrons. So scratch out electrons and replace it with the word neutrons. Identify your current concept status. Are you completely lost when you first read the question? If so, circle completely lost. Be honest with yourself. Are you weak? It's something you kind of understood. Once you get to the point where you can read this question and immediately know that the answer is mass number tells you protons plus neutrons, well then you are a pro. I did include a link here for a video that discusses mass number of isotopes. Take a look at it if you need to. Teacher talk, come ask Mr. Ford for help, ask Ms. Hegeman for help, ask a science teacher for help, ask your friends for help as your peer support. Are you going to research and repractice? Or are you feeling strong enough that you can be a peer advocate? Number 2, tell what's the same and what is different about element isotopes. What is the same is the number of protons. What is different is the number of neutrons. Remember, isotopes are atoms of the same element that have the same number of protons, but different numbers of neutrons. What is the same? Same number of protons. What is different? Different numbers of neutrons. Choose an element and list 2 things that are the same for all of the isotopes and 2 things that differ. Okay, so if we chose lithium, we would say that all 3 isotopes of lithium have 3 protons. boom, boom, boom. All three isotopes of lithium have 3 protons. That's what's the same. What is different about the 3 isotopes of lithium? Well, lithium-6 has 3 neutrons, lithium-7 has 4 neutrons, and lithium-8 has 5 neutrons. So a way to say that briefly is just to say their protons are the same, but their neutrons are different. Here's carbon-12. We also know that there's something called carbon-14. Okay, both carbon-12 and carbon-14 will have 6 protons, but they will have different numbers of neutrons. Carbon-12 will have 6 protons and 6 neutrons, which adds up to a mass of 12. Carbon-14 will have 6 protons and 8 neutrons, which adds up to the mass of 14. Explain how those differences affect the chemical behavior. This was the question that was holding most of you up. The answer here is simply that differences in mass number do not affect chemical behavior. So lithium isotopes all act the same. This lithium and this lithium and this lithium have different masses, but their chemical behavior is identical. So explain how these differences affect chemical behavior. Differences in mass do not affect chemical behavior. How do these differences affect chemical behavior? They actually do not affect chemical behaviors. Multiple choice. Isotopes of the same element have the same number of neutrons but different number of protons. Wrong. The same number of protons but different number of neutrons. Yes. Option B is your best choice. True or fix. Isotopes of an element have identical chemical behavior in most reactions. True. Their behavior is identical. Item 3. What are groups and periods on the periodic table? On the periodic table, we know the groups are the vertical columns up and down. Vertical columns up and down are groups. So group 1 all have 1 valence electron. Group 2 all have 2 valence electrons. Group 13 or 3A has 3. 14 or 4A has 4 valence electrons. So groups are vertical. Periods are the horizontal rows. We don't talk about periods that much, well, because it's not as important as groups. What are groups and periods on the periodic table? Groups are vertical columns. Periods are horizontal rows. You'll find this on day 17, 18, 19, and additionally discussed later on after day 22, and including day 22. Point to one group on the periodic table. Describe what all the elements in that group share, and also what changes across a period from left to right. Okay, so that's the same idea here. All the elements in group 5 have 5 valence electrons. So if I pointed at this group, well, all the elements in this group have 5 valence electrons. What changes as I read across a period is that the number of valence electrons increases. Group 1, 1, group 2, 2, group 3, 3, group 4, 4. Just different ways to talk about the stuff we've been learning all year long. Multiple choice. Elements in the same period share the same number of valence electrons. No. The same highest principal energy level or the number of electron shells? Yes, that is what they share. Okay. One way to think of this is every time you reach a noble gas at group 8, that valence shell is full, and then we pop over here to the next element is going to add a new electron in a new valence shell. So as you pop down the periods, you're looking at elements that have more circles in their Bohr diagram, are more energy levels. So B was the best answer to that question. The same highest principal energy level, also known as the same number of electron shells. True or fix? Elements in the same group typically have similar chemical properties because they have the same number of valence electrons. True. That's a key concept we dealt with all year long. Elements in the same group have similar chemical properties, and they do so because they have the same number of valence electrons. All right, there's a video support here if you feel like you need more support on that concept. Number 4, name and contrast 3 isotopes of hydrogen. Your three isotopes of hydrogen were right here. The first one called protium. Protium consists of one proton in its nucleus and nothing else. One proton. The second is deuterium, which has one proton and two neutrons, giving it a mass of 2 because it has 2 particles. So deuces is 2, a mass of 2, 1 proton and 1 neutron. The third isotope of hydrogen is tritium, which has a mass of 3, composed of 1 proton and 2 neutrons. So 1 plus 2 here is a mass of 3, which corresponds to the isotope tritium. So name and contrast them. Protium has 1 proton and no neutrons. Deuterium, the second one, has 1 proton, 1 neutron. And the third one, tritium, consists of 1 proton and 3 neutrons. For each excuse me, for each hydrogen isotope, state the mass number. Protium has a mass of 1, deuterium has a mass of 2, tritium has a mass of 3. Multiple choice on the same concept. Which best describes the nucleus of a deuterium atom? 1 proton? Nope. 2 protons? Nope. 1 proton and 1 neutron? Yes. Option C is the best choice here. True or fix? There are only 2 known isotopes of hydrogen. Well, no. You had to list and describe 3 isotopes of hydrogen. So there's not 2 known. There are 3 known isotopes of hydrogen. Fix that to make it say there are 3 known isotopes of hydrogen. Here's your exam schedule, by the way. If you're in my 1A or 2A class, you're taking your exam on Tuesday, December 16th. If you're on a B day student, you're taking B1 or B2 test on Wednesday, December 17th. And folks, your A4 and your B4 finals will be on Thursday, the 18th. And then you'll begin your holiday break, weather permitting. 5. Describe the atomic composition of each of the isotopes of hydrogen. That's the same idea we just went through. So once again, protium consists of 1 proton and nothing else. Deuterium consists of a proton and a neutron. Tritium consists of a proton and 2 neutrons. Draw them. So again, that's right off your day 13 work. Use the drawing to explain how the composition changes while the element still remains hydrogen. Okay, how is it possible that these 3 things are all the same if they have different numbers of particles? Remember, neutrons are neutral. So adding neutrons doesn't change the electricity and it doesn't change the chemical behavior of these 3 entities. So they all act the same, so we identify them as the same. They are all 3 hydrogen, just different versions of hydrogen called isotopes. Number 6, explain how adding light or heavier isotopes changes the average atomic mass of an element. It was amusing how many students read this question as we were putting light onto the isotopes. No, it means we're taking the isotopes and considering what happens if there's more of the ones that are not heavy, or adding ones that are heavy. So how does adding light or heavy isotopes change the average atomic mass of an element? So, for instance, here is lead, which has a average mass of 207.2 atomic mass units. So lead atoms are heavy. 207 mass units is a lot. On average, their mass is 207.2. Why is there a 0.2 there? Well, because some of them have more particles than others. So that 0.2 means on average, how much do they weigh? Some of them are not as heavy, only at 204. So the isotope of lead, 204, exists in nature at only 2% of the lead atoms. But 52%, over half of them, are actually a heavier version of lead, which has 208 mass units. Right? So what happens if nature changed and this lighter element, this lighter isotope of lead, was more abundant? What if we didn't find it 2% of the time, but what if we found it 20% of the time? Well, that would change this atomic mass average number and make it lighter. It wouldn't be as close to 208. It wouldn't be as close to 207. It'd be pulled down towards 204. Same thing with lead 206. The relative abundance right now is 24%. Well, what if this was 70%? Well, then on average, the mass would be closer to 206. And then lastly, let's look at the heavy isotope, 208. 52% of it is even heavier than 207. Well, what if that 52% were 82%? Well, then this number 207.2 might change to 207.8. It would depend on the relative abundances of the other isotopes. So let's split that up. Go ahead and identify a statement here that says for isotope 204, if it increased in abundance, then this average would decrease. Increasing isotope 206 would decrease the atomic average. And then lastly, increasing lead isotope 208 would increase the average isotope mass. Multiple choice. If isotope A, this is not the same example, this is a new example. So if an unknown isotope A has a mass of 10 atomic mass units and its abundance is 90%, isotope B has a mass of 11 atomic mass units and abundance of 10%. The average atomic mass would be closest to what? Is it going to be closest to 10, 10.1, 10.9, or 11? Well, 90% of it's at 10. So we're going to have an example that isn't 10, but an example or an answer that is closer to 10 than it is to 11. So the best option here would be B, 10.1 atomic mass units, because the majority of them are the lighter version, which means on average the mass is going to be lighter, but not entirely 10, because that would mean 100% of them were 10. Some of them are heavier, so it's pushing the average from 10 to 10.1. True or false? The average atomic mass always equals the simple average of isotope masses regardless of their abundance. Well, no, we just talked about it. If I change the abundance, that will affect the average mass. So the average atomic mass always equals the simple average of the isotope masses regardless of abundance? No. Not regardless of abundance, but depending on their abundances. Depending on their abundances.